Hi, today we'll talk about topic modeling. Topic modeling is a type of statistical method that is used to identify latent topics in a collection of documents. It's an inexpensive technique, and it is used to extract hidden topics from unstructured text so that we'll get insights and find out what are the trends. Unstructured text could be like any kind of Wikipedia article or novels or as such, right? So also the data we are trying to use is the UFO sightings data. In that we are going to use summary column, which is also unstructured. So by using this method, we eliminate manual or repetitive tasks because we are not going to label any data, and there are many algorithms, and the algorithms will automatically find out underlying themes. And like I said, it's an unsupervised NLP machine learning method. We don't have to give any label data or categories. We don't have to set any categories. And we can identify groups and clusters, and the probability of distribution of words, co-occurring words, topic-wise histogram of words as such. And there are many topic modeling techniques in NLP, and you can just look it up so that you'll get a better idea. We're just trying to get a high-level view of what is topic modeling, and we'll try to pick one technique among the many popular techniques available for topic modeling. I thought there are two popular methods which when I researched this is what I found out, that is LDA and LSA, latent directly allocation and latent semantic analysis. And it's this particular LDA model which we are trying to use is a model which is used to uncover any kind of central topics and their distributions across a set of documents. And there are several steps. Obviously, one of the simpler way to think of is you can pre-process the data. The cleaner the data, that is good for you, and remove all those inconsequential words which are not relevant in the context, and convert the text data into a TDF. Today, we're going to use Python library, open source library, which is called as Gensim. They call it as Generate Similar. So acronym is Gensim, and it's a free and open source library. And it is designed to process raw unstructured data using unsupervised ML algorithms, just like what we talked about LDA. And it will find out the statistical co-occurrence patterns within a corpus of training documents. We give a corpus, and we just try to clean it up and give a corpus. And by initializing the model, we can find out those occurrence patterns. And this is all automatic, and it will find out the semantic structure of documents. And some of the algorithms are included in Gensim are word2vec, FastTech, LSI, LSA, and LDA. And in this example, we'll try to use LDA modeling technique. And like I said already, topic modeling, we are going to use Gensim. It's a free open source library, and it will be used in our example. And it will help us in kind of representing documents as semantic vectors, and it is designed to process raw unstructured texts like we discussed. And also it is an NLP technique and unsupervised ML method, so that you get a set of terms derived from those documents. Let us try to go to their website. This is the website Gensim, and clearly they say that it's topic modeling for humans, and it will train large-scale semantic NLP models, and it will represent text as semantic vectors, and also find related documents. Typical code block could be like this, like I've highlighted. And there are many examples in this website. Please, if you get a chance, go through those documentation, and we will get a better idea. And now that we are done a brief tour of Gensim, let us try to understand what are the libraries which are necessary for us to run this example. Like always, we'll load pandas and also regular X, and also we'll try to use warnings, filters. We'll filter out some warnings. There are some depreciation warnings I'm getting, so I thought I'll try to fix them by using import time and all. So let us see that. And the data which we have already used in the previous example, scatter text, is the same UFO sightings dataset from Tidytuesday R repository, and we'll just try to go to that repository, and I'll again give you a brief tour of the website. They release weekly datasets, about 52 in a year, so it is free, and anyone who is trying to use real real world dataset, they can go to this website, and it is I think for the past 6 years they have this website, and they will also list out what is the data and what is the data type, and if the source, and if there is any associated article. So we have identified in the previous example UFO sightings that is coming from year 2023. Let us scroll down and see. It's I think 6/20 2023. Yep, here we go. We have that identified now. This is the dataset which I thought it was interesting because it has a lot of columns, and we also have a summary column which we are interested in using for NLP methods. So there are several ways. Again, this dataset, they'll give you the what type of variables and what is the data type and description of each and every variable. And there are several ways you can download this dataset. Go to that on the left hand side bottom, you can see UFO Sightings CSV. You can right click on it, save as CSV onto your desktop or wherever you feel comfortable. Or there are several methods you can go. If you have GitHub account, you can download it directly. Or in this example, what I did is I copied this particular link and went back to my Jupyter Notebook, and I pasted that in my pd.readcsv function from pandas. So as you can see, that is exactly what I did already. So that link has been pasted. Now that we have the data, identified data, and we have passed that to the readcsv function, let us try to run the cells and import the necessary libraries, and so that those libraries are available for us. And also in the next step, we will try to load the data into DF so that we have that data available. And once we have done those two things, we will try to quickly look at the data by looking at two samples so that we'll understand what the data is all about. And hopefully that data will give us a glimpse of what exactly the structure is. Yep, you can see here there are several columns. Date columns are there, city, state, country code, shape, and as such. So the column which we are interested in is summary, which has a lot of text there. It is again unstructured data, so that will be useful for us. And even though we have done visually, we'll try to use pandas info function so that we'll get a clear picture of all the columns and data. It looks like we have 96,429 rows, and there are about I think 12 columns, and each column we will know what type of the data type the column is: Boolean, float, and object type. And once we have done that, next step is that we need clean data, right, for to use LDA modeling techniques. So we'll try to clean it up. We'll try to look, for example, look to see if there are any null or missing values. Straight away we see that there are several values. So for now, let us try to clean up those things, and by passing axis equal to 0, we can remove those rows and drop NA in drop NA function. We did that, and we have the summary. And further, like I said, the cleaner the data, better for you. So I've just used a couple of techniques here. Maybe if you have time, you can clean it up further. The clean data, like you can remove a lot of characters, unwanted symbols or whatever. So simply I've created a clean text function, removed some white space and all. So I mean, it is all up to you. You can probably clean it up further. And once we do that, we have a couple of steps pending. We'll apply the clean text function and to the summary column. Once we have that, we can see 3 samples. We have those summary column, and also the left side is the index value of that particular row, so that we have those things appearing here. I think for now it looks good. Like I said, the cleaner the data, better for you. You can maybe pause this video and clean the data further. And as a first step, we will try to import a function which is already available for us called a simple process in Gensim. It's a utility function. So we will use that simple process and apply to our summary column because it also says that it will do the tokenizing and cleaning and normalizing and converting everything into lowercase and removing the punctuation, etc. So let us try to use that and run the cell. And once we run the cell, it should help us further. Like I said, if you have cleaned it up, you can also take this step so that it is much cleaner. And the second step is we need to import corpora from Gensim and create a dictionary object so that it is a mapping between words and their integer IDs. So in case if you want, you can further filter those extremes by passing those arguments. And once we do that, the next step is Gensim corpus. That is what we are going to create. And the dictionary object we have already created. So what happens is this is nothing but bag of words representation. It converts the text into a bag of words representation. And it creates list of word IDs. And you have the ID and also the frequency of that in that particular document. And again, there are certain things, right? It ignores a lot of things, right? It will ignore the words of in a document, only considering the presence and filtering frequency of each word. Now, like we have discussed initially, we'll use LDA, and once we have decided on our LDA, a couple of steps. We need to import models and initialize this LDA model. We can pass the number of topics which we want. Here I passed 15, and the first argument, there are several arguments. The models.LDA model expects. We have passed 3 of them. We have also passed the dictionary so that the model is aware of the dictionary. And when we print out the topics, probably we'll get those topic ID along with the weight and also the actual word so that it makes sense when we look at the topics. So let us run that, initialize the model. Its model is running. It will take, all these steps will take a while, a couple of minutes or so. So I'm trying to pause and again restarting. So that it will be easy for us to save time. So once we have that in place, we can print the topics like I said. That way we get the most significant topics. Then we'll also get the words following the topic ID. And that way we have those words associated with the topic and topic ID and weights. Higher the weight indicates stronger association with the topic. So once the previous step is completed, we can run this particular cell so that we have those topics, and visually we can also see the topic name and topic ID and word and the weight and as such. So now that that is done, let us run this cell. As we can see straight away, that's a topic 0. That is a weight and that is a word within the topic. Those are the words which are appearing. And also we have limited, right? We have limited number of topics to 3 and number of words to 5. So those are the words which are appearing. I think we're good to go. And I thought it's a good idea to visually see this too, right? Instead of in a this kind of format. So that is where we use something called as PyLDA visualization. It's clearly named after the LDA, PyLDA and visualization. It is nothing but it will give you it's an interactive topic model visualization, so that it will help us to interpret the topics in a topic model, so that it's easy for us when you hover over each circle, the right side bar graph will change. That is, I think that will give us an idea about what is happening in the particular model. We can visualize it pretty nicely. Now that we have, it's always load this into your virtual environment, Gensim and PyLDAvis also into your Python virtual environment. Let us run that particular cell so that we can visually see. Here we are. Those are the circles, and each circle represents a topic, like we already said. The larger the circle, it means the higher percentage of words in the topic. And if you can see, the circles are spaced apart. So the further the circles are away from each other, the more different they are. Obviously they belong to different topics. There could be overlap too. So the left hand space, like we said, those are the circles that will map our topics, and the right hand bar graph will display the most frequent terms in our model in that particular topic. So if you don't select anything, that is, everything is shown, all the frequencies. If otherwise, if you click on any particular topic, those associated words are highlighted here. So it's pretty easy, intuitive, so that you'll understand. You can make selections on up top too. You can enter the topic name and clear the topic, and as such we have in the particular model arguments, we said we wanted 15 topics. Like I said, those are listed in the legend. The red bars have terms projected frequency within the topic. Without any topic selection, it shows the most frequent words across the total model. So it's pretty good, I thought. And also, like I said, you can click on those tabs and use them, look at each and every topic which you have created. I mean, there is no limit. You can say 50, 60, 70 topics too. I have just taken 15 so that it will be easy for us to look at them. And you can click on the particular word in the bar. That also highlights. You can use the slider to adjust relevant metric. We can do that. And also, if you click on any of those, you can, like I said, you can enter the topic. 12 is what I'm entering, and see, we can scroll down a little bit. Don't worry about those depreciation warnings, but if you can just scroll down, here is the topic 12, and it will tell you what are the words in that particular topic, right? This is a depreciation warning which I'm getting in the Jupyter Notebook. Probably I need to remove it maybe at a future date to ignore them or make changes in my code. So it's a visually, I mean, obviously this above visual is very handy, and we can really visualize the LDA model output and make sense of the words and what are the words in all the different topics. So in a very short example, we could really understand, we can use topic models so that they automatically categorize. You don't have to pre-label anything. And we could easily find topics. We have added 15 topics within our documents. We have used summary column from our dataset, and we can. We understood that we can cluster the words, and this is unsupervised machine learning methodology. So it's pretty easy for us. We have done it so that this is nothing. We have barely scratched the surface, and there is a lot of things in NLP, in topic modeling.